subject AC machines to topic is single phase induction motors. So here objectives are capacitor motor, main components, working principle, torque, speed, characteristics and applications. Here this is the capacitor motor or run capacitor. We can say it is capacitor motor or run capacitor. See this one. See this one. Here capacitor motor or permanent capacitor motor. Capacitor motor or permanent capacitor motor. Features of capacitor motors. No centrifugal switch. Capacitor remain in the circuit permanently. It is of oil type. It is of oil type. This improves the power factor. So once again, the features of capacitor motors: no centrifugal switch, capacitor remain in the circuit permanently, it is of oil type, permanent capacitor is oil type. So on starting type capacitor is, for the starting purpose the capacitor is electrolyte, for running purpose it is of oil type capacitor. So there also improves the power factor at the starting time. Here also it improves the power factor. See here, the auxiliary winding, and that is starting, and capacitor is fixed in series with the auxiliary winding, and main winding and auxiliary winding both are in 90 degrees phase displaced, and the supply voltage is V, and the starting current is IST, and the main current is Im, and the resultant current is I, and this is the supply voltage V, capacitor C, and squirrel cage rotor. This is a schematic representation. This is schematic representation. So here, see here, this is the row how the motor will run to next. See how this connected. Capacitor with the auxiliary winding, and how this is rotating. How this is rotating. See, it is rotating in clockwise direction, and the supply is AC sinusoidal, and the poles are shown given figure. So how the rotor is rotating. This capacitor motor rotation. The performance, its starting and running conditions depends on the capacitance C. C is designed to have best starting and running conditions. C is designed to have best starting and running conditions. The starting torque is about 50 to 100 percentage. The performance, its starting and running conditions depends on the capacitance C. C is designed to have best starting and running conditions. The starting torque is about 50 to 100 percentage. The phasor diagram of capacitor motor. Here the phasor diagram. Here this is the voltage reference. The supply voltage is reference. It is taking as a reference voltage along with the x-axis, and here the starting current is IST, is angle leading by pi st degrees, and this motor current is Im is lagging by pi m degrees, and this IST and IST and Im nearly 90 degrees, but in actual practice this is the angle is alpha. The angle is alpha, and the resultant alpha pi is in between the voltage and I. Here the cosine angle between the voltage and current, that means the alpha which gives the V between V and I. So here Im, this Im and this IST, the resultant which gives the by parallelogram method, we can say that this is this IST, this IST is so drawn from the Im in this way, is parallel. So Im, this Im and this IST resultance gives the, this is the I, resultant current I. Resultant current I. This resultant current is so lagging with the voltage V. So here by pi. So next, here the percentage of starting torque is improved, and these characteristics, see here the speed character, the torque and speed characteristics of capacitor motor is shown. This is the, so here the capacitor start method, the starting torque is improved from 50%, more than that 50%, 50% to 100% here. The speed is increases up to certain speed, the torque is increasing, and then after the centrifugal switch conditions in previous case, but here not using the centrifugal switch. After that, after the certain speed, it is more than 80% or 70%, then torque will be goes on reducing, speed is increases from this point to this point, torque will be reducing here. So the torque is taking along the y axis and the speed is taking as along the x-axis. This is the torque and speed characteristics. So, for the capacitor, so the characteristics capacitor motor. So, here advantages of leaving capacitor permanently: high power factor and high efficiency, high power factor and high efficiency, increased overload capacity, noiseless running of the motor, increased overload capacity and noiseless running of the motor. Once again, the advantages of this permanent capacitor is high power factor, high efficiency, increased overload capacity, noiseless running of the motor, noiseless running of the motor. So, next speed, how to change the speed reversal, of permanent capacitor motor. So, it can be done by reversing either the main winding or so auxiliary winding, either the main winding, auxiliary winding. ఇది పట్టుకోపోతా, నేను వస్తున్నా ఒక 2 నిమిషాల తర్వాత వస్తా. So, here it can be the speed reversal, it can be done by reversing either the main winding or auxiliary winding reverse. So, here the applications of permanent capacitor, here suitable for applications requiring low starting torque like fans, blowers, oil burners, oil burners. Here the summary: the capacitor motor is one of the split phase motor. The phase shift is obtained by a capacitor in series with starting winding. No centrifugal switch is used, it is connected permanently. So, the capacitor is in the circuit permanently. The power factor is improved, starting torque is less. Thank you.